Let's take a look at our first problem. We got, excuse me, x is 0 power times x to the negative 8 times x to the 6. Different ways you can do this. First off, anything to the 0 power is 1. So that's 1 times x to the negative 8 times x to the 6. And then the 1 will disappear. So we got x to the negative 8 times x to the 6. Now I'm going to throw this over 1. Because we want to get rid of negative exponents. And how you get rid of negative exponents is you take them opposite of where they are in a fraction. In order to do that, you have to have a fraction. You can always create a fraction by putting it over 1. So we're going to take this x to the negative 8 and we'll move it down to the bottom, to the denominator. So this becomes x to the 6 over x to the 8th. Now when you have x to a power over x to a power, you subtract a smaller exponent from a larger one. So we got 8 minus 6 gives us 2. And we're going to have x to this power, x squared, wherever the larger exponent was. And it was on the bottom. And then by default we put a 1 up on top. Always have a placeholder for the other position. Our second problem. We got x to the negative 6, x to the negative 8 over x to the 8th. Well, this is already in fraction form, so it works out well. Never want negative exponents, so I'm going to take this x to the negative 6, move it down below. Now I'll take this x to the negative 8 and move it down below. Now since there's nothing left up on top where you got the 1 becomes visible, and that x to the 8th is still down there, we take the x to the negative 6 down below and it becomes x to the positive 6, and we take the x to the negative 8 down there and it becomes x to the positive 8. Again, anytime you move anything opposite of where it's at in a fraction, the sign of the exponent changes. Well, now we got x to a power times x to a power times x to a power, so we're going to add the exponents. Well, 8 plus 6 is 14, plus another 8 is 22. Yeah, 22. And then that would be our answer. Our third problem says, want to simplify this. We got 28y to the 5th over 4y to the 4th. First off, let's look at the numbers. We got 28 and 4. Those are both divisible by 4. 4 divided by 4 is 1. 28 divided by 4 is 7. So that gives us 7y to the 5th over y to the 4th. Well, again, when you have y to a power over y to a power, you can subtract a smaller exponent from a larger one. So we got 5 minus 4 gives us 1. And we're going to have y to the first power where our larger exponent was, which is on top. And then we have a placeholder of 1 down there. And of course, y to the first is just y, and 7y divided by 1 is just 7y. And that's our answer. Number 4. 6x to the negative 6x to the negative 5th, y to the 0, and 4x to the negative 2, y to the 3rd. Okay. First off, notice that y to the 0, that's equal to 1. So that can just drop away. So we got 6x to the negative 5 and 4x to the negative 2, y to the 3rd. Okay, we got negative exponents, and we know we need to take the part of the negative exponent opposite of where it's at in a fraction, so we have to create some fractions. So I got 6x to the negative 5 over 1, and over here I'm going to have 4x to the negative 2, y to the 3rd over 1. Again, you can always create a fraction by putting it over 1. Now the part with the negative exponent, specifically in this one the x to negative 5, we're going to take down to the denominator. And over in the second fraction here. We're going to take the x to negative 2 and move it downstairs. Now when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So the x to negative 5 becomes x to the positive 5. Here we got 4y to the third. Those don't move. But the x to negative 2 becomes x to the positive 2. Now once I put something else down here besides 1, I don't need those 1s anymore. Well, nothing really left to simplify after that, so we'll go ahead and multiply across. 6 times 4 is 24. And we have y to the third. And down below, we got x to a power times x to a power. Remember, if you're multiplying x to a power times x to a power, you add the exponents. So that would give me x to the 7th. And that's my answer. Okay, problem number 5. It says simplify the expression by using properties of exponents. So we got y to the third to the negative 1 power. Well, this one, there's different ways you could do it, but to begin with, we could raise this exponent to this exponent. When you raise one exponent to another exponent, you multiply them together. So 3 times negative 1 gives us negative 3. Now we don't want negative exponents, so I'm going to put this over 1, create a fraction, and we're going to move the part with the negative exponent opposite where it's at in a fraction. So this y to the negative 3, I'll move down below. And when I move it down to the denominator, it becomes y to the positive 3. And then we got a placeholder of 1 up there. That would be our answer. Number 6, negative 2x squared over y to the negative 1 to the third power. Well, we don't want any negative exponents. Now, negative numbers are fine. Now, negative 2 doesn't bother us, but this y to the negative 1 does. So I'm going to move that up on top. When I do that, you move anything opposite where it's at in a fraction, the sign of the exponent changes. So it becomes y to the positive 1. And we got a placeholder of 1 here. And then to the third power. Of course, these 1s don't do anything, so I can drop them. So we got negative 2x squared y to the third power. Now I told you that this should be called the distributive property of exponents. It's not, but it should be called that. If everything inside of your parentheses is either multiplication or division, and you're raising it to a power, you're going to take everything to that power. Well, everything's multiplication. We got negative 2 times x squared times y. So we're going to take the negative 2 to the third power, we're going to take the x squared to the third power, and we'll take the y to the third power. So we got negative 2 to the third power, we got x squared to the third power, and we got y to the third power. Now negative 2 times negative 2 is positive 4 times another negative 2 gives us negative 8. X, and when raising one exponent to another exponent, remember you multiply them together. 2 times 3 is 6. Y, and y to the third power is just y to the third. So our answer is negative 8. Negative 8 x to the 6, y to the third. And number 7. Okay. Simplify the expression using properties of exponents. Still doing the same thing. So we got 3x squared y to the negative 1 over y squared raised to the third power. Well, again, we're going to work on what's inside the parentheses first. Order operations always tells you to do that anyway. And we got a negative exponent. Never want negative exponents. So that y to the negative first power I'll take down to the denominator. So we're going to have 3x squared over y squared. And the y to the negative 1 becomes y to the positive 1 to the third power. Can still do a little bit of simplifying inside the parentheses. Y squared times y to the first, y to a power times y to a power, you're going to add the exponents. 2 plus 1 is 3. So we got y to the third power. All of it raised to the third power. Now again, I said this should be called a distributive property of exponents. If everything inside of your parentheses is either multiplication or division, and you raise it into a power, you can take everything up to that power. Well, notice we have 3 times y squared divided by y to the third. Everything's multiplication or division. So I'm going to take the 3 to the third power, I'll take the x squared to the third power, and I'll take the y to the third power. Okay, so we got 3 to the third, we got x squared to the third, and we got y to the third. Now 3 to the third is 27. 3 times 3 is 9 times another 3 is 27. X, and when you're raising one exponent to another, you multiply them together. 2 times 3 is 6. And down here, you're raising one exponent to another, you multiply them together. 3 times 3 is 9. So our answer is 27x to the 6 over y to the 9th. Okay, number 8. We got 2 times 3x to negative 2, y to the third to the negative 1 power. Order operations. Tells us first do what's inside the parentheses. So let's start there. And right away inside the parentheses I notice I got a negative exponent. So I'm going to write this in fraction form. And again, you can always create a fraction by putting it over 1. And then I'm going to take this x to negative 2 and I'll move it down to the denominator. So we got 2, and then up on top we got 3y to the third, and down below the x to negative 2 becomes x to the positive 2 to the negative 1 power. Okay, I'm still following my order operations. I'm doing everything inside the parentheses. There's nothing left inside the parentheses. Well, now we have a fraction to a negative power. Whenever you have a fraction to a negative power, you flip the fraction, take reciprocal of it. So top goes bottom, bottom goes to the top. So we're going to have x squared over 3y to the third. And then the sign of the exponent becomes positive. So it becomes a positive 1. Well, first power doesn't do anything. So we're left with 2 times x squared over 3y to the third. And I could, if I needed to see it, put the 2 over 1. So we got it, and then x squared 3y to the third. Reason why we do that is if you're multiplying exponents or multiplying fractions, they both should be fractions. So now we'll multiply the top parts together. 2 times x squared is 2x squared, and we'll multiply the bottom parts together. 1 times 3 gives us 3 with a y to the third, and that's our answer. Okay, number 9. We want to evaluate the given polynomial. So we're gonna, they tell us y is negative 4 and x is 2. And we've got negative 6x to the third minus 5yx plus 3. Well, to evaluate this polynomial, we're going to go through and replace all of our variables with parentheses. So I got negative 6 times parentheses to the third power minus 5 times parentheses plus 3. Now notice everything else has remained exactly the same. We've just gone through and replaced all of our variables with sets of parentheses. Now x we said was 2, so everywhere I had an x I'll put in a 2. Now y we said is negative 4, so everywhere I had a y I'll put in a negative 4. And now you follow your order of operations. Please excuse my dear Aunt Sally. Please do what's inside the parentheses, nothing to do inside the parentheses. Exponent. Well, here's our first exponent, 2 to the third. Actually, it's our only exponent, too. 2 to the third is 8. And then we got negative 5, negative 4, 2, plus 3. Please excuse my dear, multiplication division is count either one from left to right. Here's first multiplication. We got negative 6 times 8 is negative 48. Everything else carries down. Still doing multiplication and division. So our next one is this right here. So we're going to have negative 48. Negative 5 times negative 4 gives us a positive 20. And then 2 carries down with parentheses drawn it. Still doing multiplication and division. Here's a 20 times 2. Which gives us 40 plus 3. Please excuse my dear Aunt Sally. Addition and subtraction. So I'll do this one here. Negative 48 plus 40 is negative 8. And last addition and subtraction, negative 8 plus 3 gives us negative 5. And that's our answer. Let me save this page. And unit 4, page 01.pdf. Okay. Start a new page. And we'll look at problem number 10. And need to bring that up. That's a video game I was playing. Computer game, I should say. Okay. Number 10. We got x is equal to 3. We got y is equal to negative 1. And replace the variable in the polynomial with a specific value and determine the value of the polynomial by performing the indicated operations. So we got 9y minus 5x y to the third plus xy squared. Okay. Evaluating is always the same. We go through and we replace the variables with parentheses. So I got 9 times parentheses minus 5 times parentheses the third power plus parentheses times parentheses squared. Seems kind of bizarre, but again, just everywhere we had a variable, we'll replace the set of parentheses. Everything else remains exactly the same. The 9, the minus 5, the third power, and then the second power here. Now, wherever we had an x, we'll put in 3. Wherever we had a y, we'll put in negative 1. Okay. Order of operations. Please do what's inside the parentheses. There's nothing to do inside the parentheses. Excuse exponents. Well, here's our first exponent, negative 1 third power. So we're going to have 9 times negative 1 minus 5 times 3. Now negative 1 third power gives us a negative 1. Negative 1 times negative 1 is a positive 1 times another negative 1 is a negative 1. Plus 3 times negative 1 squared. Please excuse, I'm still doing the exponent part. Our next exponent is this right here, negative 1 squared. So I got 9 times negative 1 minus 5 times 3 times negative 1 plus 3, and negative 1 squared is 1. I got rid of those parentheses around the 3 because they weren't doing anything anyway. Please excuse my dear multiplication division. Here's my first one. 9 times negative 1 gives us negative 9, and everything else carries down. Still doing the multiplication and division. Here's our next one. Negative 5 times 3. So we got negative 9. Negative 5 times 3 is negative 15. And I'll bring down the negative 1. Plus 3 times 1. Still doing multiplication and division. Here we got negative 15 times negative 1. Which gives us a positive 15. Plus 3 times 1. Still doing multiplication and division. Here's 3 times 1. We got negative 9 plus 15 plus 3. Please excuse my dear Aunt Sally. Here's our first addition and subtraction. Negative 9 plus 15 gives us 6 plus 3, and then our last one is 6 plus 3, which is 9. And that's our answer. Okay, let's look at number 11. We got 8x squared plus 2. And it says determine if the expression is a monomial, binomial, or trinomial. Well, it's got two terms. Remember, terms are separated by pluses and minuses. So it's got one term here and it's got one term here. So it's two terms, which means it's a binomial. Now it says determine the degree and leading coefficient of the polynomial. Now leading coefficient implies it's in standard form. It's arranged from largest power down to smallest, which this is. Your degree, when all you got is x's, your degree is your largest power of x, which would be 2. And the leading coefficient is, you take a look at your first term, that's called your leading term. And the number that's in front of the x to whatever power, that's your leading coefficient. So a leading coefficient would be 8. And that's our answers. Number 12. Okay, we got 7x squared plus 9x plus 5. Same questions. Is it a monomial, binomial, trinomial? Well, it's got three terms. Remember, terms are separated by pluses and minuses. So here's our first term, here's our second term, and here's our third term. So it's a trinomial because it's got three terms. Now our degree. Our degree is the largest power of x if all you have is x's, so it'd be 2. Now our leading term is that when it's in standard form, which this is, x squared x, no x, your leading term is your first term. And the leading coefficient will be the number that's in front of it, which is 7. And those are our answers. Okay, let's take a look at number 13. We got x squared plus 8 inside of parentheses minus x squared minus 4. First off, we always want to get rid of parentheses. Now these first set of parentheses aren't doing anything, so I can just drop them. Now remember, if you have a negative out in front of your parentheses, this is going to flip a sign of everything inside. So it's going to flip a sign of the x squared and the negative 4. So the positive x squared becomes a negative x squared. The negative 4 becomes a positive 4. Now adding and subtracting these basically means combining together like terms. Here we got an x squared minus x squared. Well, those are going to cancel. And here we got 8 plus 4, which is going to give us 12. And that's our answer. Let's look at 14. We've got negative 5x squared minus 6x plus negative 6x squared minus x. Okay, first off, we want to get rid of the parentheses. So I'll drop those first set of parentheses. So I got negative 5x squared minus 6x. And then we'll get rid of those second set of parentheses. So we got negative 6x squared minus x. And that plus there I can actually get rid of. But when you got a plus between them, the parentheses really aren't doing anything. Well, we want to combine together like terms. Here's an x squared, and here's an x squared. Negative 5, negative 6 gives us negative 11 x squared. Remember, combining like terms, you add or subtract the numbers that are in front of them. And here's an x, and here's an x. Negative 6x, and there's an invisible 1 here. Negative 6x and negative 1x gives us negative 7x. And that's our answer. Now notice I'm putting them in standard form also, where the terms are arranged from largest power down to smallest. Okay, number 15. Got 3x squared minus 6x and then minus 7x squared plus 9x. And, okay. So we're going to subtract these. Again, get rid of the parentheses. First set of parentheses isn't doing anything. Now our second set of parentheses, we have a negative out in front of it. Remember that negative is going to flip sign everything. So flip sign of the 7x squared and of the 9x. The positive 7x squared becomes a negative 7x squared. The positive 9x becomes a negative 9x. Now combine together like terms at any step. Like terms, same variable to the same power. So we got 3x squared minus 7x squared gives us negative 4x squared. Here we got an x, and here we got an x. Negative 6x and negative 9x gives us negative 15x. And that's our answer. Okay, number 16. We got 7x squared plus 5x plus 1 plus x plus 7. And I want to add these together. And our first step is to get rid of parentheses. These parentheses aren't doing anything because this is a plus here. So we got 7x squared plus 5x plus 1 plus x plus 7. Okay, now we want to combine together like terms. And our first one's x squared. There's only one x squared, so that just stays by itself. Here we got an x, and here we got an x. So again, we want to add or subtract the numbers that are in front of them. We got 5x plus, there's an invisible 1 here, so 5 plus 1 gives us 6x. Numbers, we got 1 plus 7, which gives us 8. And that would be our answer. Uh, 17. 8x plus 8 minus the negative 3x squared minus 2x plus 2. Well, the first set of parentheses didn't do anything, so we can just drop it. So we got 8x plus 8. Second set of parentheses, we got a negative in front of it, so that's going to flip the sign of everything inside. So flip the sign of the negative 3x squared, the negative 2x, and the positive 2. So the negative 3x squared becomes a positive 3x squared. The negative 2x becomes a positive 2x, and the positive 2 becomes a negative 2. Now we want to combine together like terms. Like terms, same variable, the same power. So put the x squared first, start with the largest power. We don't have any other x squared, so we don't need to worry about that. Here's an x, and here's an x. Well, 8x plus 2x gives us 10x. And here's an 8, here's minus 2. 8 minus 2 gives us 6. And that's our answer. Let's see, number 18. Multiplying monomials. So we got 5x y to the fourth times 5x to the third y Okay. Now when you're multiplying monomials, you multiply the like items together. When I say like items, you multiply the numbers together first. 5 times 5 is 25. And then you multiply the x's together. We got x times x to the third. Now remember, if you just have an x, that's like an invisible 1 there. So that's like x to the first. So we got x to the first times x to the third, and we're going to add the exponents. 1 plus 3 gives you 4. Now we multiply the y's together. Y to the fourth times y, and remember y, again, is like you have an invisible 1 here. So y to the fourth times y to the first, you add the exponents. So 4 plus 1 gives us y to the fifth. And that's our answer. Let's see, number 19. We got 3x times negative 3x minus 2. Now notice here we have a monomial out in front and we have a binomial in here. This is a distributive property. We're going to take this 3x, we'll multiply it times our first term inside the parentheses, and we'll multiply it times our second term. So we got 3x times negative 3x, and we got 3x times negative 2. Now 3 times negative 3 is negative 9, x times x is x squared, 3 times negative 2 is negative 6, and then the x carries along. And that's our answer. Okay, number 20. We multiply these two together. So we got 3x minus 3 times 2x minus 2. Now I'd like to use my line method on this. We got a binomial here, 2 terms, and we got a binomial here, 2 terms. So I'm going to take my first term, the 3x, and I'll multiply it times the first term over here, and I'll multiply it times the second term. And then I'll take my second term in the first set of parentheses, and I'll multiply it times the first term over here and times the second term. Well, let me write out what I just said. Take our first term times the 2x, and we'll take our first term times the negative 2. Then we're going to take our second term, the negative 3, multiply it times the 2x, and we'll take the negative 3 and multiply it times the negative 2. All I'm doing is following the lines here. So 3x, and I follow the line, multiply times the 2x, and multiply times the negative 2. Here I follow the lines, negative 3 times 2x, and negative 3 times negative 2. Now 3 times 2 is 6, x times x is x squared. 3 times negative 2 is negative 6x. Negative 3 times 2x gives us negative 6x. And negative 3 times negative 2 gives us a positive 6. Now no matter where you are in algebra, you should always combine together like terms. So we got negative 6x and negative 6x gives us negative 12x plus 6. And this would be our answer. Okay, this one's a little bit bigger. Negative 3x plus 5. I guess I'll start down here. And then multiply that times negative 3x squared minus x minus 1. Okay, now we got 2 terms here and we got 3 terms over here. So I'm going to take my first term over here, the negative 3x, and I'm going to multiply it times the first term over here, times the second term, and times the third term. Let me write that out first. So we got negative 3x times negative 3x squared, negative 3x times negative x, and negative 3x times negative 1. So again, took my first term here and multiplied it times each term over here. Then I'm going to take my second term, the 5, and multiply it times each term over here. So I'm going to take 5, multiply times negative 3x squared. I'll take the 5, multiply times negative x. And I'll take the 5 and multiply times negative 1. Okay, negative 3 times negative 3 is 9. And x times x squared gives us x to the third. Remember, there's an invisible 1 here. X to the first times x squared, you add the exponents. Negative 3x times negative x gives us positive 3x squared. Negative 3x times negative 1 gives us a positive 3x. Negative times a negative is positive. 5 times negative 3 is negative 15 with an x squared. 5 times negative x is negative 5x. And 5 times negative 1 gives us negative 5. Always combine together like terms. There's only one x to the third. Here we got an x squared. Here we got an x squared. 3x squared minus 15x squared gives us negative 12x squared. Here I got an x, and here I got an x. 3x minus 5x gives us negative 2x. And then the minus 5, we only got one number, so that carries down. And that's our answer. Let me save that. Okay. Start a new page there. Go back to our PDF. And let's take a look at number 22. We got x minus 3 x squared plus 3x plus 9. And we want to multiply these together. Well, our first term, the x, we're going to multiply it times each term over here. So I'll multiply it times the x squared, I'll multiply it times the 3x, and I'll multiply it times the 9. Well, actually, let me go ahead and do that first. Okay, so we got x times x squared. We got x times 3x. And we got x times 9. Well, then we're going to take our second term. We'll take the negative 3 and multiply times each term over here. So I'll multiply times the x squared times the 3x and times the 9. So I got negative 3 times x squared, negative 3 times 3x, and negative 3 times 9. Well, x times x squared gives us x to the third. X times 3x gives us 3x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times 3x gives us negative 9x. And negative 3 times 9 gives us negative 27. No matter where you are in algebra, you always want to combine together like terms. Here's an x squared, here's an x squared. And 3x squared minus 3x squared actually drops away. That's interesting. 9x minus 9x drops away. And we're just left with the minus 27. I guess that is a difference, 2 cubes, which we'll see shortly. Okay, 23. We got 4xy plus 9x minus 9 times y, and we'll multiply them together. Well, we got 3 terms here and we got 1 term here. You always start with your one with the smallest number of terms. So we work from it. So I'm going to go from this direction. So we got the y here. We're going to multiply it times each term over here. So I'll multiply it times the first term, times the second term, and times the third term. Okay, so we got y times 4xy. We got y times 9x. And we got y times negative 9. So that's going to give us 4x, and y times y gives us y squared. Again, you multiply the like items together. So you multiply the y's together. And the rest of it just carries down. Now here, these are all different. I got a number, I got an x, I got a y. So I'm just going to put them next to each other in alphabetical order. 9xy. And y times negative 9 gives us negative 9y. Now, we can't combine together like terms here because they have to have the same variables, the same powers. So that would be our answer. Okay, 24. And stop just a second. I swear I got a pop somewhere here in my bag. There it is. Need to hydrate. Okay. Okay, let's look at 24. So, bring it down a little bit. Got x plus 5. And we got x minus 8. Now it tells us to multiply the binomials using the FOIL method and combine like terms. Really, there's not much difference between that and what we've been doing. We've got two terms and two terms, and the only time you can actually FOIL it is when you've got two terms times two terms. I'm going to take my first term here, which is the x, and I'll multiply it times the first term over here and times the second term. Let me go ahead and write that down. X times x, the first. X times negative 8, the outer. Now I'm going to take the 5 and I'll multiply it times the x over here, and I'll multiply it times the negative 8. And so we're going to have 5 times x, the inners, and we'll take 5 times negative 8, the last. So I make it sound like it's something brand new, but this is the same thing we've been doing. So x times x is x squared. X times negative 8 is negative 8x. 5 times x is 5x. And 5 times negative 8 is negative 40. Now you should always combine together like terms. Like terms, same variables, same power. So here's an x and here's an x. So we got x squared, negative 8x plus 5x gives us negative 3x. And then I'll bring down the minus 40. And again, notice it's always in standard form. Largest power down to smallest. Okay, 25. We got 3x plus 2 times 4x minus 1. Okay. It says FOIL again, but again we know that this is foiling. It's just drawn with lines. So multiply the 3x times the 4x, and 3x times negative 1. So the first of each, 3x times 4x. Then 3x times negative 1, the outer. So the 3x and negative 1s are outer. Then we're going to take our second term here, this 2, we'll multiply it times the 4x and times the negative 1. Well, 2 times 4x, that's our inner. And 2 times negative 1, that's our last. Last in each parentheses. Well, 3x times 4x gives us 12x squared. 3x times negative 1 is negative 3x. 2 times 4 is 8x. And 2 times negative 1 is negative 2. Which gives us 12x squared, negative 3x plus 8x gives us 5x, and minus 2. And that's our answer. Number 26. Another FOIL. Part of the problem with FOIL is people don't know when to use it. That's why I like doing the line method, because then it doesn't matter what it looks like. You just follow the lines, and that helps you figure out what to multiply everything by. And it's actually doing FOIL when you got two terms and two terms. Again, FOIL is when you do have two terms and two terms. But it doesn't matter. I start with my first term here, and I multiply times every term over here. Okay, so we got negative x times 6x, and negative x times 9. And then we'll take our second term, the negative 1, and we'll multiply it times the 6x and times the 9. So negative 1 times 6x and negative 1 times 9. Well, negative times positive is negative, and then 6 carries down. X times x is x squared. Negative x times 9 is negative 9x. Negative 1 times 6x is negative 6x. Negative 1 times 9 is negative 9. Always combine together like terms. We've got negative 9x and negative 6x, which is going to give us a negative 15x. And then bring them down to minus 9. And that's our answer. Okay, 27. X plus 4 times x minus 4. Now these have something unique about them. Gives you hints. Says find the product of binomial factors using appropriate special product, blah blah blah. Well, First off, these are conjugates. Conjugate means the first parts are the same, x and x. Last parts are the same, 4 and 4. And then the sign in the middle is different. This is positive and this is negative. When you got conjugates, all you have to multiply together is your first parts and your last parts. And I'm going to do that, talk about that after I work the problem. Let's say I don't see that. So I want to multiply these together. Well, we'll take our first term here, the x. We'll multiply times the x over here and multiply times the negative 4. Okay, so we got x times x and we got x times negative 4. Then we'll take our second term here, the 4, and we'll multiply times the x and times the negative 4. So 4 times x and 4 times negative 4. Well, x times x is x squared. X times negative 4 is negative 4x. 4 times x is 4x. And 4 times negative 4 is negative 16. Always combine together like terms. Negative 4x plus 4x is going to cancel. And we're left with x squared minus 16. Okay, we said these are conjugates. And all we have to do is multiply our first parts together and our last parts. X times x would have gave you x squared, and 4 times negative 4 gives you negative 16. So a very simple way to solve that if you spot it. If you do not spot it, it's no big deal. See how they drop away anyway. Let's look at 28. X plus 3 squared. Earlier in this video, I said it should be called a distributive property of exponents. If everything is either multiplication or division inside of a parentheses and you're raising it to a power, you can take everything inside the parentheses to a power. We don't have that here. We have a plus. So you cannot take the x to the second power and the 3 to the second power. The plus is what screws it up. What we have to do here is you have to rewrite it as x plus 3 times x plus 3. And now we're going to multiply just like normal. There's actually a formula for doing this, but why memorize another formula when your steps will work no matter what? So I'm going to take this first term here, this x, and we'll multiply times the x over here and times the 3. So we got x times x times 3. And then we'll take our second term, the 3, and multiply it times the first term over here and times the second term. So we'll take 3 times x, and we'll take 3 times 3. Well, x times x is x squared. X times 3 is 3x. 3 times x is 3x, and 3 times 3 is 9. Which gives us x squared. Always combine together like terms. Like terms, same variable, the same power. 3x plus 3x is 6x. And that would be our answer. Okay, number 29. We got 4x plus 4y to the second power. Now I'm just going to look ahead. I'm just curious how many problems there are. Oh, okay, we're real close to getting done. Okay. Then I'll have to wait for 45 minutes for it to process. I'll go back to my game, though. That's what I use to kill time while I'm uploading. I don't like to do other work because I'm afraid I'll screw up the uploading. Okay, now again, I cannot square the 4x, cannot square the 4y because of the plus in here. Everything inside has to be multiplication for you to do that. So all we're going to do is rewrite this. This will be 4x plus 4y times 4x plus 4y. Okay, so we're going to take our first term here, this 4x, and we'll multiply times each term over here, times the 4x and times the 4y. And then we're going to take our second term, the 4y, and we'll multiply it times each term over here. I think you've seen enough colors. 4x times 4x, 4x times 4y, then 4y times 4x, and 4y times 4y. So this term times this term, this term times this term, this term times this term, and then this term times this term. Okay, 4 times 4 is 16, x times x is x squared, plus 4 times 4 is 16, xy, 4 times 4 is 16 xy. Now notice I put those in alphabetical order. If you put them in alphabetical order, you can easily identify the like terms. And 4y times 4y, 4 times 4 is 16, and y times y is y squared. Always combine together like terms, same variable, the same powers. So we got 16x squared, 16xy plus 16xy gives us 32xy, plus 16y squared. And that's our answer. Okay, number 30. 4x minus 4 times 4x plus 4. Well, kind of the same thing as this. It's just already written in that form, except for it doesn't have the y's. So we'll take our first term here, the 4x, multiply times the 4x over here, and then multiply times the 4. Let me write that out. Okay, 4x times 4x. 4x times 4. And then we'll take our second term here, the negative 4, and we'll multiply it times the first term over here and times the second term. So I got negative 4 times 4x and negative 4 times a positive 4. 4 times 4 is 16. X times x is x squared. 4 times 4 gives us 16x. Minus 4 times 4 is 16x. And then negative 4 times 4 gives us negative 16. Now always combine together like terms. Same variables, the same powers. So 16x minus 16x drops away. And we got 16x squared minus 16. Did you spot that they were conjugates? Firsts are the same. They're both 4x. The last are the same. 4 and 4. Sign in the middle is different. This is a minus and this is a plus. Again, if you spot their conjugates, then you can multiply the first parts together and last parts. 4x times 4x gives you 16x squared. Negative 4 times 4 gives you negative 16. And those would be our answers. And I think that's the last problem. Yes, it is.